Okay, what if I told you there's this one tiny component and it is so fundamental that without it, our entire modern world would just stop? It's the unsung hero inside everything you love. And its job? Well, it's basically a microscopic bouncer running the most exclusive party in the universe, the party of electricity. So today, let's get on the list. And I am not kidding. The device you're watching this on right now, it has billions of them. Billions. Your calculator, your car, your weirdly smart coffee maker. Yep, everything electronic is built on a mountain of these tiny little gatekeepers. But what are they actually guarding? You heard me. A bouncer. All of modern technology, the entire digital age, is basically run by a bunch of impossibly small nightclub bouncers. They're the ones deciding who gets into the party and who has to wait outside. Stick with me, I promise this is going to make perfect sense. All right, so the fancy official name for our little bouncer is the Bipolar Junction Transistor, or just BJT for short. And despite that very technical sounding name, its job is surprisingly simple. It's all about control. Look, a BJT really only does two things, but it does them incredibly well. First, it can act as a simple on-off switch. It either lets electricity flow or it slams the door shut. Or, second, it can act as an amplifier, taking a teeny tiny weak signal and turning it into a big, powerful one. A switch and an amplifier. That's it. That's the foundation of literally everything. So how does our whole nightclub thing map to the real deal? Well, a BJT has three little legs, or terminals. First up, you have the collector. Just picture this as the massive line of electrons, that's our current, all waiting outside, desperate to get into the club. Then you've got the base. This is our bouncer, the one in charge, the control pin. And finally, you have the emitter. That's the exit. Electrons want to flow from the collector, through the club, and out the emitter. But they can only do it if our bouncer at the base gives them the nod. Now, it turns out there isn't just one kind of BJT club. Nope. There are two main establishments in town, and each one has a slightly different door policy. You've got the NPN club, and you've got the PNP club. So the NPN club is the one you're going to see most often. Think of it like this. A small current flowing into the base, kind of like slipping the bouncer a small tip, opens the main doors wide open. The PNP club, it's the total opposite. It works when a small current flows out of the base. So for NPN, the signal goes in to turn it on. For PNP, the signal has to come out. That's really the main difference you got to remember. So, okay, we know the bouncer's the boss, but how do we actually tell them to open the doors? How do we control this flow of electrons and really get the party started? Well, it all comes down to a tiny little cover charge. See, for most of the silicon transistors you'll ever use, our bouncer won't even glance your way until you give them at least 0.7 volts between the base and the emitter. It's the absolute minimum cover charge. Anything less, and that velvet rope is staying right where it is. And this isn't some random number. It's the actual energy needed to get things moving inside the silicon itself. Once you pay that tiny voltage fee, the bouncer's all ears. And this, right here, this is where you see the transistor's real superpower, amplification. That little Greek symbol there, beta, is basically the bouncer's generosity level. If beta is, say, 100, it means for every 1 electron you send to the base, the bouncer lets 100 electrons rush in from the collector. It's nuts. This is exactly how a tiny whisper of a current from something like a microphone can be blown up into a massive shouting current that's powerful enough to drive a huge speaker. So this all builds up into the bouncer's three main moods, or what we call operating states. First up is cutoff. This is when there's no cover charge, no tip, nothing. The bouncer's ignoring you, the doors are locked, the club's empty, the transistor is off. Next is the active region. You've paid the cover, you're giving the bouncer a small, steady tip, and now they're letting people in proportionally. This is the sweet spot for amplification. Finally, we have saturation. This is when you've given the bouncer such a huge tip, they just throw the doors wide open, the club is at max capacity, it's a fire hazard in there, the transistor is fully on, and it literally can't let any more current through. Okay, so we've got the analogy down. We know how it works. But where do these little bouncers actually work? Well, it turns out pretty much everywhere. Their first big gig is in amplifiers. Think about a microphone picking up your voice. It creates this tiny, weak electrical signal. By feeding that signal into the base of a transistor that's in its active region, we can create a much larger but identical copy of that signal, one that's powerful enough to drive a big speaker. And their second job, which is maybe even more common, is as switches. By just flipping a transistor between being completely off, that's cutoff, and completely on, that's saturation, we create an electronic switch that has 0 moving parts. This is the fundamental action behind all digital logic. It's how computers think in ones and zeros. It's this right here. And then, what happens when you take billions, and I mean literally billions, of these tiny transistor switches, and you pack them all onto a single chip of silicon? You get a microprocessor. Every single calculation, every decision your phone or computer makes is just the result of this coordinated dance between billions of electron bouncers turning on and off at incredible speeds. All right, the party's winding down. We've been to the club, we met the bouncer, we saw how the whole thing works. So let's do a quick recap just to make sure we don't get turned away at the door next time. So just remember, BJTs are tiny little electronic components that act as either a switch or an amplifier. They've got three parts: the collector, where the main current is waiting in line, the base, which is our bouncer, our control gate, and the emitter, which is the exit. A tiny, tiny signal at the base controls a huge flow from the collector to the emitter. They come in two main flavors, NPN and PNP, and they are, without a doubt, the bedrock of our entire digital world. So the next time you pick up your phone or turn on your computer, just take a second and remember the billions of microscopic bouncers working tirelessly inside, managing the flow of electrons. They are the hidden gatekeepers of the information age. And now that you know how they work, the only question left is, what party are you going to start?